topic was inspired by this paper. Not all images are perfectly taken in studio, especially when the task is to detect objects for robot vision, security, or transportation, but it was difficult to do small object detection. In this 5 minutes video, I will start with what is object detection and the roadmap of it. Next, I will briefly go through and show the result from the two models in the experiment. And finally, I will wrap up with the link to the actual code in PyTorch. Without further ado, let's dive in. Object detection comes with localization and classification. It recognizes what the object are presented and where in the image the object are located. Before 2012, when there wasn't many computational resources, scientists used the traditional object detection model. The modern way to detect now is using convolutional neural network, also called CNN, and they are divided into one-stage and two-stage detector. Before getting into experiments, recall what are these detectors. Two-stage detector is a regional proposal-based framework. Some significant algorithms like RCNN, FastCNN, and RFCN. What they do is to generate a regional proposal, extract features with CNN, and do classification and bounding box regression. YOLO SSD, on the other hand, belongs to one stage. One stage does both regional detection and object classification using one network. I will pick SSD and faster RCNN for today's demonstration. The pre-trained object detection models can be found on PyTorch model builders that are available for everyone to use. Faster RCNN model with a ResNet 50 FPM backbone are based on this paper. Another model I will be using is called SSD300 model. It is based on the SSD single-chip multi-box detector paper. Feel free to check out these two papers for more details. Both models are trained with the COCO datasets. Object detection models are usually built with backbones, NIC, and head. Each part takes care of different tasks. First model, let's call it faster RCNN, has the backbone of ResNet 50, the NIC of feature pyramid network, and the head is faster RCNN. FPN is a feature extractor. It is effective at detecting small objects. The other model is called single-chip detector SSD. It has the backbone of VGG16, the neck of NMS, and the head of SSD. According to the paper from this graph, we can see that some variation of faster RCNN and SSD are on the two ends when it comes to accuracy and computational cost. Our objective of the experiments is to test out the assumption that faster RCNN with FPN will give us good result in detecting small objects, but with a longer time, and SSD will do the opposite. Let's dive into the experiments. Here are two beautiful HD images. The left is taken from Port Nananga and the right is at Rondomont. We'll put these two images into inference model. In order to keep high confidence, we'll set 0.7 as the threshold. Look at the tiny people walking on the coastline. Faster RCNN with FPM is able to detect them. Look, it also detects the red umbrella on the right hand side. Even I can spot it in the first place with my human eyes. Let's look at the result from SSD. It doesn't detect small objects. Putting all the results together, faster RCNN detects the class person with an average confidence score of 0.86 and the umbrella with 0.676. On the other hand, SSD can detect any objects given that we set a really high confidence threshold. The runtime of SSD is 7.3 seconds, which is faster than faster RCNN. This result matches our assumption. Very nice. Let's take the experiment at Rondomont. We got this result from faster RCNN. The result is impressive. Many bounding boxes with high confidence score. And move on to SSD. This is the output. Not so good. Again, putting the result from each model side by side, faster RCNN detects many classes. It detects the class person with a very high average confidence score of 0.912. Benches, handbags, and clock are also being detected, but the time is long though. It takes almost twice the amount SSD would take, but SSD is only able to detect person with 0.785. Isn't the experiment interesting? I've put the link to the code. Feel free to try out more image. With the recent development of object detection in computer vision, algorithms like feature vision, reception field, attention layer, and edge augmentation are introduced to do small object detection. Which other real-world application do you think small object detection can apply to? Let me know. Finally, these are the amazing references that I've learned from. Thank you for watching. Have a great day ahead.